Welcome this evening. There's just a few more people rolling in, but welcome to this webinar. So this webinar is decarbonisation enough, which is being put on by the IET Solent network. So we're a group of volunteers that deal with the Solent area, being from Southampton over to Portsmouth in the south of England up to around Winchester, that sort of southern Hampshire sort of area. We are putting on a series of events this year in 2021. So this is the first of our decarbonisation theme. So several more along theme throughout this year. Just a bit of housekeeping on the webinar system works that we've got. There is a chat box, but there's also a Q&A box. So if you'd like to ask a question, please type it in at any time, but make sure it's in the Q&A box, because that's the one we'll be monitoring for questions. And then after the lecture, we'll go through as many as we can. We've got quite a lot of audience, so we might not get through them all. But thank you for joining us. And I'm going to hand over to my volunteer colleague, Martine, who will introduce us to the speaker. So Martine.
Thank you, Dean. Good evening, everyone. A warm welcome to everyone who joined us wherever you are worldwide. We are volunteers from IET Solent. We are today joined by Professor Ian Arbon on a subject, is decarbonisation enough? With interest on how best we can combat a climate change, or that, and with interest on how best we can respond to the sustainability requirements and the sustainability initiative. Back then, about 3-4 years ago, happened to participate on a course in Glasgow University, where Professor Ian was one of the professors, and introduced us to sustainability in the sense of environment, energy. And when we've been talking about how best each one of us can contribute, and we find opportunity that in particular nowadays, where UK government is looking to how best those initiatives can be implemented. We had a word with Professor Ian, and was keen to introduce us to this evening on some of his findings. So please join me to welcome Professor Ian tonight. Thank you. Professor Ian, I'll hand you to you.
Okay, thanks very much, Martine. For that introduction. I'm going to turn my video off because our bandwidth is not great, and I think that will help the presentation. So I'll reappear again at the Q&A session afterwards. So could we have the next slide, please? So just to introduce myself personally, I'm the unusual combination of a career businessman, a chartered engineer, a chartered environmentalist, and a part-time academic. So I address this topic from much more than the viewpoint of a single vested interest. I've spent over 50 years in manufacturing industry, mostly in the UK, but also in other countries. I started as an apprentice and worked through many roles in industry before moving into senior corporate management as managing director or chairman. For most of those 50 years, I've supplied sophisticated engineered equipment into the energy industry, both fossil and renewable, around the globe, and know the sector very well. For the past 25 years in our engineered solutions consultancy, I've become heavily involved with sustainable systems, especially considering greenhouse gas emissions from all sectors and their impact on the global climate and ecosystems. Next. So for the past 15 years, I've been a visiting professor successively at Newcastle, Glasgow and Strathclyde universities, as well as lecturing worldwide on sustainability, particularly in the United States, believe it or not. Most of the material in this presentation is based on the MSc module, Energy Policies, Politics and Ethics, that I taught from 2006 to 2019 on Newcastle University's Reflex and Euring courses. And just a disclaimer that all the views and opinions expressed in this presentation are mine and Engineered Solutions. They are not attributable to any of the above mentioned universities or to IMechE or other engineering institutions. That's not to say there aren't a lot of people who agree with me, but that's just to make it clear that these are my views and I'm not implicating anyone else. Okay. This is just a repeat of the abstract, but you will have seen that in the publicity for this event, so we'll take that as read and move on to the next slide. So the full title of this webinar is "With the UK's ambitions to lead in achieving net zero greenhouse gas emissions by 2050, is decarbonisation enough?" Well, this question almost presupposes a negative response. So let's look at the underlying issues here. Although expressions such as decarbonisation, low carbon, and net zero have become very popular in the past few years, they are not scientific or engineering terms which will enable us to ensure a more sustainable world. They appear to have become targets within themselves rather than enablers to achieve the real target, which remains climate change mitigation and adaptation. A great maxim which I have followed closely for many years is borrowed from the McKinsey Corporation. If you cannot define it, you cannot measure it. If you cannot measure it, you cannot manage it. So if we're serious about climate change mitigation and adaptation, we must first be clear regarding our definitions. One of my favorite quotations regarding definitions comes from Victorian children's literature. "When I use a word," Humpty Dumpty said in rather a scornful tone, "it means just what I choose it to mean, neither more nor less." That comes from Lewis Carroll's Through the Looking Glass, which was the sequel to Alice in Wonderland, which you might have heard of. Well, that was a problem then in terms of communication, but the problem is even more serious today, where changing the meaning of words is being used, and I suspect perhaps deliberately, to obfuscate and to divert attention from our failure to make any real positive impact on climate change, the intended goal. So we should start with clear definitions. Contrary to current popular belief that the answer to all our problems is to demonize carbon, I have to say this is manifestly absurd. A basic understanding of chemistry shows us that carbon is a solid with a molar mass of 12, is one of the main building blocks of our planet, and is the basis of all organic chemistry. Similarly, we human beings have a high proportion of carbon in our chemical composition, around 18.5% by mass. It would be impossible for life on Earth to exist without carbon. Carbon is the main component of sugars, proteins, fats, DNA, muscle tissue, pretty much everything in your body. So a zero carbon future, as we sometimes hear mentioned, does not bode at all well, either for us or for the planet. Of course, many people use carbon as an abbreviation for carbon dioxide, but this is also extremely misleading. And just to define it, carbon dioxide, CO2, is a gas with a molar mass of 44. Get to that by adding the atoms together, 12 plus 16 plus 16. And since carbon has a molar mass of 12, any confusion of the two will result in figures being wrong by a factor of 2.4. And believe it or not, people do it all the time, and it's exceedingly irritating. Carbon and CO2 are very different chemically, and they behave in radically different ways. Unlike carbon, CO2 can be emitted to the atmosphere, where it acts as one of the so-called greenhouse gases, GHGs. These are not technically pollutants. It's worth noting that they're not technically pollutants, but even in the very small quantities in which they exist, that's usually measured in parts per million by volume, these have a serious influence on global warming and climate change. So let's just look at or remind ourselves what the greenhouse effect is. And here on this slide, you have a picture, so a fairly standard picture explaining the greenhouse effect, which I'm sure many of you will have seen before. But it shows the sun's rays coming down through the atmosphere to reach the surface of the Earth, and then reflecting back up into the atmosphere. But in the middle of the picture, you see a layer there called greenhouse gases. And the effect of those greenhouse gases is to trap or prevent some of those reflections going back into the upper atmosphere, and trapping that heat on the surface of the Earth, thereby making it warmer than it would otherwise be. And because it acts like a greenhouse, it's called the greenhouse effect. So clearly, the greenhouse effect is not a bad thing. Without the greenhouse effect, life on Earth as we know it would not exist. There's always been a certain level of greenhouse gases in the atmosphere, otherwise we wouldn't be here. The problem is that since the start of the Industrial Revolution, a couple of hundred years ago, we have been producing too much of it, and the levels keep going up and up. In order, the Earth's most abundant greenhouse gases are water vapor, carbon dioxide, methane, nitrous oxide, ozone, and chlorofluorocarbons. So you can see that focusing solely on carbon dioxide is not necessarily helpful. Next. When these gases are ranked by their contribution to the greenhouse effect, the most important are water vapor, which contributes by far the most, then carbon dioxide, the one we focus on, which is certainly a large contributor, then methane. And although methane is smaller, its effect is more severe than carbon dioxide, and then ozone, which is a smaller amount. So from this data, it's difficult to understand why the government and NGOs have become fixated on CO2, or carbon as they confusingly call it, alone. This is unlikely, I have to say, to have any significant effect on climate change. We need to consider all of these. It's just an illustration of Greta Thunberg's famous zero carbon voyage across the Atlantic to New York. And I just wanted to point out that on this zero carbon voyage, Greta and her crew, being human beings, consisted of high quantities of carbon, as we have seen. Their very expensive boat, way beyond the means of most of us, is almost entirely made from carbon fiber. So while this was a commendably low emissions, but not zero emissions, Greta and her crew were emitting themselves, this voyage was not remotely zero carbon. So we need to get these things in perspective. It's also worth noting that her support crew actually flew across the Atlantic to the meeting in New York. So from the foregoing, it should be evident that clearly and correctly defining our goals and objectives is crucial to actually achieving those objectives rather than just talking about them. And there's been plenty talking and little action. In the 30 years since the publication of the first report by the Intergovernmental Panel on Climate Change, or IPCC, we have done little more than pay lip service to the problem, and climate change has continued unabated. Some of us are already calling them the 30 wasted years. We now have the opportunity to spend the next 30 years to 2050 rectifying this situation, but we must start with the correct definitions. The one word that clearly defines this is sustainability, and our objective should be to achieve true sustainability by 2050. This concept was first formulated by the Brundtland Report of 1987, but over the last 10 years, this has been largely obscured by the use of fairly meaningless slogans. So some of the best known and memorable definitions of sustainability are the Brundtland definition itself: development that meets the needs of the present without compromising the ability of future generations to meet their needs, their own needs, sorry. Or a very simple statement, which I really like: we have borrowed the present from our children. I've put there, it's an old African proverb. I've heard it attributed to many different parts of the world, but wherever it came from, it's a really interesting statement. We've borrowed the present from our children. This is all entirely consistent with the United Nations Sustainable Development Goals of 2015, which some of you will be familiar with, but it's not reflected at all in recent government energy and environment policy. Some years ago, to try to combat this, in FIMechE, we mapped out a sustainable way forward for energy and environment policy called the energy hierarchy. So the concept of the energy hierarchy was first developed within FIMechE in the early 2000s, and it was publicly launched at the ICOMES conference in Brussels in 2007. And following widespread endorsement from other international engineering institutions, it was published as an FIMechE policy statement in 2009, and you see a picture of that there. Last year, we updated this document because of the importance we gave to it, and it has now been republished by FIMechE and is freely available on their website, and I'd commend it to you. The basic principle in the diagram on the left, which comes from the statement, is a 5-tier approach, starting with the most sustainable at the top, which we've called energy demand reduction, followed by energy efficiency, followed by utilization of renewable sustainable resources, followed by utilization of other low greenhouse gas emitting resources, and finally, utilization of conventional resources as we do now as being the least sustainable. So it's a simple concept with profound outcomes. The energy hierarchy follows the rule that a kilowatt saved is more valuable than a kilowatt produced, no matter by what means. Similarly, the higher up the hierarchy we go, the more sustainable the process. So just to unpack that a little, next. Energy demand reduction simply means do not use as much energy. And the second tier, energy efficiency, means find more efficient ways of supplying and using energy. The third, renewable, sustainable energy resources, those with the least environmental impact. Fourth, other low greenhouse gas emitting energy resources, so the others that reduce or produce less or fewer greenhouse gases. And finally, conventional way, the way we currently do it. So how it works, the first tier of the hierarchy, energy demand reduction, is a demand side measure, which often requires lifestyle change, but has the greatest, quickest impact on demand reduction and greenhouse gas emissions. It should be obvious that a greater impact can be made by saving a kilowatt of energy than finding a better, cleaner way of producing a kilowatt of energy. This concept is also known, particularly in America, as the negawatt. Examples of this are using all forms of motorized transport less, insulating buildings better, passive solar and low emissions building design, turning thermostats down, holding virtual meetings and conferences, etc., as we're doing this evening. Before COVID-19, this was considered almost impossible in a developed society such as the UK, yet now we can all see the benefits, particularly environmental, that have ensued. Second tier, energy efficiency, is both a demand and supply side issue. On the demand side, this requires the use of low energy appliances and lighting, highly efficient space heating devices, micro CHP heat pumps, electric, hybrid, and low fuel consumption vehicles. On the supply side, this involves making much better use of energy input to energy output ratios, such as combined heat and power, district heating schemes supplied by electricity generating plant. Engineers must play the primary role here, but energy efficiency has to be promoted and rewarded by government, and it has simply not been so far. However, care must also be exercised to avoid Jevons paradox, this appeared in the 19th century, that increasing energy efficiency may simply lead to greater energy consumption, which is defeating the objective. So the third tier, which is renewable, sustainable energy, is a supply side measure involving the use of fuels which have the lowest overall, that is the whole life cycle, environmental impact, and which meet the other sustainability criteria, economic and societal. Almost all renewable forms of energy can also be considered to be sustainable, although care must be exercised, for example, with large-scale hydroelectric schemes. Biomass and other biofuels are also important renewable fuels, but require careful whole life cycle analysis to ensure sustainability. Engineers will continue to lead development in this tier but care must be taken to ensure the achievement of the first two tiers is prioritized so that the targets to be achieved are not continually growing. The fourth tier, which is using other low GHG emitting energy resources, is another supply side measure which includes other energy supply technologies which achieve reductions in overall life cycle greenhouse gas emissions. This can include thermal power generation from cleaner hydrocarbons, for instance, or nuclear, although these have other environmental and societal issues which have to be addressed in a sustainability analysis. Although the current UK practice of gratuitously wasting the co-generated heat energy must cease. Lower carbon content vehicle fuels will also significantly cut down greenhouse gas emissions, but may well have other sustainability issues. Hydrogen as an energy vector may also be included here, although it also has significant sustainability issues which must be addressed. And since this is a field I do a fair bit of work in, I would have to say it's not being addressed nearly enough currently. So if the first four tiers can be successfully implemented, then it follows that the fifth tier, that is doing what we currently still do, but perhaps a little bit better, need never take place. And existing forms of power generation, space heating of buildings, and fueling of motor vehicles can eventually be phased out. This also means that continued exploitation of finite reserves, especially fossil fuels, will decline and will become much less of a strategic issue. So let's apply the principles of IMECE's energy hierarchy to current government policy. I want to preface all of this by saying, because I will be fairly critical of these, that I am not saying that I have any problems with what these reports are proposing. That's not my point. My point is that they are not going far enough to achieve climate change mitigation. So just bear that in mind. So I'll just refer briefly to this, but because it's so important to current energy policy in the UK, in May 2019, the Committee on Climate Change, the CCC, produced this report, Net Zero, the UK's contribution to stopping global warming. And it's largely been adopted as the UK government's policy on energy and the environment, as shown in the current energy white paper that's being considered. So, as I've noted, the UK's Committee on Climate Change is the body which is largely responsible for introducing the now ubiquitous term net zero. In the foreword to its recent report, which now forms the basis of current energy policy, it states, by reducing emissions produced in the UK to zero, we also end our contribution to rising global temperatures. Well, this statement is manifestly untrue. The emissions from manufacturing of the huge number of products that we all consume in the UK, but which we have outsourced to places such as the Far East, remain our contribution to rising global temperatures. We cannot simply ignore these facts to reach our goals, and yet that is what is being done. I'll move on then to the government's recently announced 10-point plan for a green industrial revolution, with the slogan "Building Back Better, Supporting Green Jobs and Accelerating Our Path to Net Zero." Again, I stress, I don't have a problem with what they're proposing. I'm far from convinced that it will meet that, that slogan. So just to look at these points, there's the 10 points listed, and I won't repeat them because we're going to go through them one by one. So we move on to the next slide. First one is advancing offshore wind, producing enough offshore wind to power every home, quadrupling how much we produce to 40 gigawatts by 2030, supporting up to 60,000 jobs. Well, I'm saying this is a welcome about turn from government on wind energy. I've been working in and around the wind sector for over 30 years, so I have a fair bit of experience of how little support we've had from government, indeed sometimes outright opposition and hostility to the sector. So this is a welcome about turn. But the installation rate that they mention of 40 gigawatts by 2030 means a rate of 4 gigawatts per year. That is 400 times 10 megawatt turbines each year. Now, I'm fully aware that that is purely a measure of capacity anyway in gigawatts. It's a power rating. It is not the amount of energy we produce, which they produce, which would be measured in gigawatt hours. But just leaving that to one side for the moment and focusing on the power capacity. I think the likelihood, I've chosen a 10 megawatt sort of average size of what might happen over the next 10 years, 10 megawatt turbine. If we install 400 of those each year, that's more than one a day. And as a practical engineer, that fills me with serious apprehension. That is a lot of installation. The other aspect is that no UK manufacturer, there is no UK manufacturer of offshore wind turbines. There's certainly some potential for support structures, but limited facilities. I'm based here in Scotland, and we've had a major crisis recently with the failure of a company called Bifab, which would have been a major potential supplier of foundations and floating structures for offshore wind, and was part owned by the Scottish government, but has now gone into receivership. Of course, that many wind turbines will produce massive intermittent power generation, but there is no mention at all in this document, or indeed in the CCC's document, of large-scale energy storage or of upgrade of the national grid to achieve this. So while it's good, there are an awful lot of things missing. And in any case, in energy hierarchy terms, it's only tier 3. Driving the growth of low carbon hydrogen. As you can imagine, I worry about that term, low carbon hydrogen. Hydrogen has never contained carbon in its history. But again, they have not bothered to define what low carbon hydrogen is. There's no reference to the huge level of unknowns and challenges of using hydrogen, a molar mass of 2 in place of natural gas molar mass of 18. Now, let me stress that I have nothing against using hydrogen. As it happens, I have over 50 years of practical experience of compressing hydrogen, which I suspect very few people involved at the moment do. And it again fills me with apprehension that we are not considering the unknowns and the challenges before jumping into such heavy commitments. In our case, we're looking at an installation rate of 500 megawatts of new capacity each year from a standing start. That is huge. And again, in energy hierarchy terms, it's still tier 3 or tier 4, depending on the source of the hydrogen. Third point is delivering new and advanced nuclear power. Advancing nuclear as a clean energy source across large-scale nuclear and developing the next generation of small and advanced reactors could support 10,000 jobs. Well, I have to say, clean energy source is highly debatable, and lots of people would not agree with that. The other thing is with certainly what we've experienced in recent times with nuclear is that this will make little practical difference by 2030, which is the interim goal of this report. There's no clear intention, as I've mentioned before, to recover the vast quantities of wasted heat energy. So this is still mid-20th century thinking. At the smaller end of the scale, I think there's some good potential of using small modular reactors in local communities, but there is no experience of doing this in this country, and we could expect the resistance from those communities to be quite high. The big issue, of course, with nuclear power anyway is that it's unsustainable by the definitions we've used because it leaves problems to future generations to resolve. So in energy hierarchy terms, this is tier 4 or 5. Point 4, accelerating the shift to zero emission vehicles and backing our world leading car manufacturing bases, etc., to accelerate the transition to electric vehicles and transforming our national infrastructure to better support electric vehicles. So they say zero emissions, but they seem to be talking exclusively about EVs. And other countries, we might consider ourselves world leading, but other countries are already more advanced than the UK in EV development and production. And while last week it was certainly excellent news that Nissan is considering bringing a battery manufacturing plant to Sunderland alongside its car factory, that is good news, no question. But at the same time, we know that other international manufacturers have decided that the UK is not where they want to develop their electric vehicle technology. As we all know, the cost of EVs is crucial to widespread deployment. It's likely to be the domain of the rich in the UK for the foreseeable future, that is to 2030. There's certainly no coherent national plan for charging infrastructure in the UK. It's being done very much on an ad hoc basis. In energy hierarchy terms, this is probably tier 2, so it's clearly a good thing to do, but as I say, there are many obstacles. The fifth one, green public transport, cycling and walking, making cycling and walking more attractive ways to travel and investing in zero emission public transport of the future. It, as I note, is the first of the points based on behavior change and energy demand reduction. So obviously I'm very much in support of this. But we have to note that not everyone is capable of cycling and walking, and we have to beware of discrimination. I think also it's a mistake to include public transport in the same point. I think, as we've all seen, the serious effect that COVID-19 has had on public transport, we probably need to have a complete rethink of where public transport really fits into future scenarios in the UK. And I just note that nothing is truly zero emissions. Zero is a very clearly defined number. And missing from this is your journey really necessary warning, cutting down on the need for transport. But nevertheless, it's good, and in energy hierarchy terms, it would be tier 1, except public transport, where I think, as I said, we need a rethink on this. On point 6, Jet Zero and greener ships, supporting difficult to decarbonize industries to become greener through research projects for zero emission planes and ships. I think that's more of a pious hope than a clear objective. It's full of greenwash type words. The thinking is unchanged over the past 2 decades, during which time the problem has greatly increased. COVID has shown us that significant reduction in air travel is achievable. Much can be replaced by the internet, but this requires nationwide high-speed broadband, an area where the UK lags badly behind other countries. The massive rise in ocean shipping over the past 3 decades, which is created, as I mentioned before, by the amount of manufacturing we have offshored, which gives us much lower costs and also helps us to evade the greenhouse gas emissions from that manufacture. I don't see how that can continue to be treated the way it is at the moment, and a total rethink is required on this. In any case, we're looking here at energy hierarchy tier 4 or 5, I think. 7's greener buildings, making our homes, schools and hospitals greener, warmer and more energy efficient, while creating 50,000 jobs by 2030 and a target to install 600,000 heat pumps every year by 2028. Well, it's certainly another good example of greenwashing. It completely misses the point of energy demand reduction, which requires behavior change. And I'd have to say, as someone who, I realize that heat pumps are in vogue at the moment and are highly regarded, but I have to say I've been working with industrial heat pumps for over 35 years now. And I'd have to say that installing heat pumps in existing properties without first putting in heavy thermal insulation is simply not sustainable. My view, all new buildings should be built to passive house standard. And this is energy hierarchy tier 4, where it should be 1. So investing in carbon capture usage and storage, becoming a world leader in the area, and so on. As I've often noted with my students, CCUS is a device which neither captures nor stores carbon. Carbon dioxide is captured and then stored as carbon dioxide. It is not safely sequestrated as carbon, which is where it came from. This is a serious issue because as I've noted further down the bullet points, it's an unsustainable process because it leaves problems to future generations to resolve, but also it significantly worsens the overall energy efficiency of the associated plant, which works against the energy hierarchy. It certainly adds significantly to the overall capital cost of the plant, and its energy hierarchy tier 4 at best. The 9th, protecting our natural environment, planting 30,000 hectares of trees every year whilst creating and retaining thousands of jobs. I'd have to say this is an excellent idea, although it's only peripherally to do with energy or industry. The ambitious, very ambitious objective of planting 30,000 hectares per year has to be contrasted with the willful global destruction of 31.5 million hectares per year of well-established tropical rainforest. Now, it's more serious even than those numbers, because what we would be planting would be young trees that will take years to soak up much carbon dioxide, whereas the trees that are being cut down are very well established and contain large quantities of sequestrated carbon. There's no mention in this of societal, economic, or wider environmental impacts of change of land use, and there will be those. Brief reference to more efficient farming, but nothing on the likely need for a more vegetarian future, which I'm afraid is going to be almost unavoidable. The energy hierarchy is not really applicable to this, but it's nonetheless a good idea. And 10th, the green finance innovation, developing cutting-edge technologies needed to reach these new energy ambitions and make the City of London the global centre of green finance. Well, as a businessman, I have to smile a little at this because my experience over the years of trying to get the financial sector to support cutting-edge technologies has not been great. But there's an interesting contrast here with the CCC's claim that there is no need for new technologies. So there's a wide divergence of viewpoints there. There's no methodology for ensuring that new products or technologies developed in the UK will also be made in the UK. And this is a long-standing traditional issue. It's not at all clear why or how the City of London would become a global centre of green finance. And in energy hierarchy terms, the UK financial sector is notoriously dismissive of energy efficiency and energy demand reduction. So again, we're going to have a few problems there. So just to conclude with a way forward for net zero. The past 200 years or so, the aftermath of the Industrial Revolution, the UK, along with many other countries, has had a policy of trying to reach strategic energy objectives by focusing almost exclusively on supply-side technologies. Unlike most other Northern European countries, little thought has ever been given to reducing energy demand to make energy supply objectives more readily achievable. Since 1990, when the first IPCC assessment started to make us all aware of the need to mitigate and/or adapt to climate change, the UK's energy goals and targets have become increasingly more based on sustainability goals. Despite this, the proposed methodology of achieving these goals has remained firmly with a greener, cleaner supply side. Making efforts to reduce energy demand has not met with any success. So consequently, the 10% renewable electricity by 20 target that we set in 1997 was not achieved. the 10% renewable transport energy and 12% renewable heat energy by 2020 that was set in 2010, these targets were also badly missed. Yet, despite this poor track record, virtually all of the measures that are being proposed to achieve the 2050 net zero greenhouse gas emissions are also supply-side technologies with only slight improvements over what has gone before. This really does not augur well. To paraphrase G.K. Chesterton, it is not that energy demand reduction has been tried and found wanting, it has been found difficult and left untried. This is because a prerequisite of energy demand reduction is human behavior change. Unless each of us changes the way we live, we will go on trying to consume more and more energy. Even the CCC, which at first stated that no new technologies are required to reach the 2050 target, then produced its 2019 report proposing a largely technology-based supply-side solution, has now changed its mind. In December 2020, the CCC issued a further document which stated that just 41% of the net zero target will be achieved by technology alone, 43% by a mixture of technology and behavior change, and 16% just by behavior change. While this is welcome, it most certainly is, it's a big change, it's an enormous shift in viewpoint and fully justifies IMechE's approach in the energy hierarchy policy statement. I would go further and say that behavior change will be the key, because technological developments and implementation will not be fast enough to achieve the 2050 targets. However, behavior change is required not only in individuals like us, but also in multinational corporations and governments. In many years of lecturing on this subject, I have been fairly consistently told that human behavior change is just too difficult for people in the developed world to embrace. However, the present COVID-19 crisis has changed all of that. Behavior change has been forced upon us, and the results have been amazing. Energy consumption in the UK is down to levels not seen since the 1960s. Globally, climate scientists are already saying that 2020 will show the lowest recorded greenhouse gas emissions in decades. If nothing else positive comes out of this terrible pandemic, let us make sure that the new normal after the crisis is over does not simply revert to our old energy wasteful ways. Following the principles of the energy hierarchy will help us to ensure that our world will indeed be a cleaner, greener place for our children and grandchildren. Following quotation is apt. This comes from Rachel Carson's 1962 book, Silent Spring, which virtually began the environmental movement, which I reread during lockdown. Humankind is challenged as it has never been challenged before to prove its maturity and its mastery, not of nature, but of itself. If we are serious about achieving the goal of net zero greenhouse gas emissions by 2050, it will require behavior change. We cannot rely solely on supply side technologies and for government and MNCs to implement them. Much of it will be down to us. So I commend the principles of the energy hierarchy to you. Well, thanks very much for listening, and I'm sure there will be some questions.
Thank you very much, Ian. Yes, there are indeed some questions coming through, quite a few actually. One that I will very quickly cover is that there's been a question about CPD certificates, and yes, they will be available shortly after the event from the IET website. So I'll just cover that quickly. So we have a question here on, a lot of them are relating to government policies. So is there a push to ensure the government requires solar panel installation in new build projects?
Yeah, well, there's certainly moves in that direction, and it's obviously a good thing to do. But again, it's not a complete solution because we're still relying on supply side technologies rather than looking at the demand side, which is what I've been speaking about.
Okay.
I should say I do have my own 4 kilowatt PV array, by the way, which is sometimes a bit of a waste of time in southwest Scotland, but I'm certainly not against PV.
So during the presentation, you said water vapor was a major greenhouse gas or effect contributor.
Yeah.
Is any of this man-made, and how do we influence that or reduce that?
Well, it's a very good question, and it's a question I asked of Sir John Horton, who I worked with for some years, who is one of the country's leading climate science and chair of the second and third IPCC assessments, and he said, well, we don't think water vapor has a very big effect. So if that was his response, and I have immense respect for him, I don't think I can say what effect it does have. You know, it certainly isn't taken as a very serious problem to be dealt with. Some of it will, of course, be man-made. Some of it otherwise.
Thank you. With the trials undertaken off north and west of Scotland and the potential for more consistent energy generation, presumably than wind there, why are tidal generation solutions not being given more emphasis and backing?
Yeah, well, again, we're back to supply side technologies, but I'm again a fan of tidal energy. The problem is that at the moment, the advantages of there are considerable advantages of tidal energy, but we haven't yet found one that is commercially viable. That's the main obstacle to them being implemented. I don't think it's an in principle problem.
Okay. Could you give us a little more detail on what you meant by passive solar and why that ended up in hierarchy level TO1?
Yeah, passive solar, it's a German term, is a house or building design is widely favored particularly in the Germanic countries of Europe, although not exclusively, which rely on various aspects like passive solar, but also very high levels of insulation and triple glazing, and mechanical air circulation to achieve extraordinarily low levels of heating requirement for the building. In fact, in most applications, no form of heating is required to keep the building at an acceptable temperature. And I've witnessed this in Germany with snow lying on the ground outside the building.
So you did mention in the presentation briefly about how with the inconsistency of things like wind generation, we might need a storage upgrade to the national grid. Is the concept that's been passed around a few times of using people's plugged-in electric vehicles while they're at home as distributed grid storage something that's being seriously considered, or is it even likely to work?
Yeah, it certainly captured people's imagination. I can think of all sorts of reasons why in the real world it won't work, or at least not work very well. But I think the main concern I have is that you're not really moving the discussion on from battery storage. And battery storage is only really suitable for very short term, very short duration energy storage. And what we will need for, if we have offshore wind farms anything like the size that the government is proposing, is very large scale energy storage, pumped hydro or compressed air or liquid air or even hydrogen, just to provide the level of long duration storage that we're going to unquestionably need. And my concern is that that has just not been addressed by government at all.
So there's quite a few questions come through all around kind of the behaviour change that you've suggested is going to be required. Things like what can individuals do for this behaviour change, and is the government thinking of, or could they be inspired to help the public understand what individuals can do better? Yeah.
Well, yes, it's a good question. I think the big problem is that I don't think government is at all convinced that there's a need for behaviour change. I think we're the CCC's report, the 10-point plan, is heavily based on technology, and that is our traditional method of having big companies do things for us rather than taking the matter into our own hands, which is what I'm suggesting, and changing our lifestyles to cut down. So I suspect it will be a very long time before government gets around to telling us how we should behave. So and being the sort of people we are, if government told us that's how we behaved, we'd probably do the opposite anyway. But it's for each of us, I think, to look at our own lifestyles, look at our energy consumption, look at our travel patterns, and see how we can reduce those.
Thank you. So if all greenhouse gas emissions ceased today, would we still need to remove them from the atmosphere, or would the problem resolve itself?
Yeah, this is a very in question at the moment, and obviously, if we could remove greenhouse gases from the atmosphere, that would be a major help in achieving the goals. But I don't know of anything that is anywhere close to market yet that would do that. Now, that's not suggesting for a minute that I don't think such technologies are good. I think that it would be superb if we could have those. But and we probably won't be able to reduce the amount of greenhouse gas in the atmosphere without such devices. But personally, I think the likelihood of having them much before 2050 is unlikely.
How insulated should a house be before considering a heat pump? Is the normal level of kind of loft and cavity upgrades sufficient, or do people need to go further?
Yeah, that's it's a good enough question, but it really depends on the house. All houses are radically different in terms of their energy losses. The ideal is the passive house standard that we were talking about a few minutes ago. I personally live in a 150-year-old former hill farm in the west of Scotland, which has random stone-built walls, and I've spent an absolute fortune in insulating the property in terms of practicing what I preach, and I will certainly never see a financial return on that. So I think that's the bigger concern. Is you know, the simple answer is put in as much. If you're not designing the building as a passive house, at least put in as much insulation as you possibly can in all possible areas. But that's expensive, and I think unless the government comes up with some serious levels of money for people to retrofit insulation on their homes, it just isn't going to happen, because, as I say, very hard to get a financial return on it.
There's been quite a few questions. I don't know whether you'll have a comment on this, on whether a financial incentive would be a good solution for changing public behaviour.
I'm sure it would. My concern on that is not in principle at all. It's just given the that coming out of COVID, the country is going to be in serious financial hock for many years to come. I just don't know where such funding would come from.
So there's also been a question on who are the advisors that have helped put together the 10-point plan, because obviously it seems to contradict some of the points in the IMechE's energy hierarchy and so on. So were some of the engineering institutions involved in that consultation and that sort of packet of work?
Well, I sincerely hope not, but it would be a first if they were. The advisors on most government energy policy are usually economists. Engineers are not normally considered to any great degree in government energy and environment policy. I realize this is straying into a separate area of how do you value an engineer, but I just very briefly, the government, and not just the present one, but successive governments in the UK have seen engineers as the people who are going to make their plans happen, not people who should have any input to the plans. And that is, I would have to say, even more so under the present government.
So you discussed quite a lot demand side policies and the fact that a lot of policies are supply side at the moment. What area or sector could the demand side policies be applied to have the biggest impact? And are there any countries that are currently implementing better demand side policies from a government level?
Well, yes, I think there are certainly countries that are doing better than we are, but but having said that, we're not the worst. But the biggest area of biggest obvious area is in travel. That's an area where we can make a very significant difference just by not traveling as much as we are doing. And that's why I mentioned the lessons that we've learned from COVID. There has been a dramatic reduction in the number of flights, as the airline industry keeps telling us. There's been a dramatic reduction in the numbers of people commuting to work because many of us are working from home. And what would be an absolute catastrophe would be if we just go back to the way it was before, traveling without any consideration given to the effects of what we're doing. I know that's easy to say and very hard to actually implement. And I speak as someone who's spent most of his career as a frequent flyer internationally around the world, and over the past few years, I have deliberately, and long before COVID, I've deliberately tried to cut down on that, and have succeeded to a very large degree, not entirely, of course. But I think the future is going to be in the kind of communication that we're doing this evening, virtually. And the thing that really bothers me is that we are so far, in the UK, we are so far behind many other countries, probably most other countries, in terms of high-speed broadband being rolled out to everyone. The reason I had my video off during the presentation was that we have a very dodgy broadband connection here, which, fair enough, you might say you chose to live in the countryside, but we keep being promised that it's going to be rolled out to everyone, and it's just nowhere near the case. I know people who live in towns who have even worse connections than we do. So, but that is absolutely crucial to a traveling less future. So I think, if the government were to divert a considerable amount of money in that area, instead of just relying on the telecoms companies to do it on their behalf, I think we could make some major strides forward in that area.
What advice would you give to engineers in the fossil fuel or defence industries, if any, about what they can do to help?
I'm not sure I want to answer that question.
That's fine. We can move on.
I'm not. I don't want to evade the question. That wouldn't be fair. But obviously, these. I think it's quite clear that fossil fuels are not going to be with us for very much longer. At least in theory, and before somebody jumps in to correct me, I'm fully aware that fossil fuel usage is still on the increase worldwide, regardless of what might be happening in this country and other European countries. But in sustainability terms, sustainability is incompatible with fossil fuels. So sooner or later, we're going to have to get out of them.
So there's a lot of areas in the country and the world where things like diesel generators are used as backups for
Yep.
utility outages. Is there, beyond batteries, is there any other technology that can be used in that scenario?
I don't think there's very much that is available at the moment. There are ideas out there, and I think that's an area that we need to focus on. And it is a real issue because the government is talking about outlawing diesel fuel by 2030. And at the same time, as we speak, all of the emergency generators that are being built for that were being built for the new to support the new Nightingale hospitals are diesel generators. So there's a clear contrast there. And my own view is that it's going to take us an awful lot longer than 2030 to get away from the use of diesel. Be very fortunate if we manage it by 2050, but nevertheless, that is the government's goal.
There's one here back towards passive house, I think. Can an energy efficient building have an adequate supply of fresh air flowing through every part?
Yes, I mentioned the passive house system, for instance, uses a mechanical circulation system with air-to-air heat exchangers, so that you're not you can maintain the temperature of the house, but using fresh air. So yes, fresh air circulation is crucial to that design of house, because obviously it is effectively hermetically sealed.
Do you think ammonia powering of aircraft has some potential? There's been a recent IET talk on it, and it looked like a promising emerging technology.
Yeah, it could be. Certainly, I think there's very little chance of aircraft, commercial aircraft, running on pure hydrogen. So we need to find another way of doing that. Ammonia happens to be an industry I know exceedingly well. I've been working in the ammonia sector for 45 years. I'm a great fan of what ammonia can do, but I'm also painfully aware that ammonia is also not a nice benign substance. It's very toxic, and it's highly corrosive of many metals, and has an ammonia leakage is much nastier than most gas leakages, in that ammonia effectively dissolves all of the mucous membranes in the human body. So as I say, it's not something to be taken lightly. With all of these new ideas, we can see the great advantages. Of course we can. But we need to also look at how do we actually address the serious challenges for the widespread use of these.
And one to finish, I think, because we're approaching our finish time, really. But so we talked about demand reduction, and one of those being things like passive house standard for new builds and so on. But do you think there's enough research being done on how to implement those sorts of standards and techniques into the existing infrastructure of offices, houses and factories? Because obviously it's currently a very difficult and expensive activity So is enough being done, or is the focus on new builds?
Well, I don't think there's much focus at all in this country. I think that's part of the problem. You compare what we do here nowadays. I went to, just a personal example, in 1977, I went to live in Germany, and I couldn't believe the levels of insulation that they had in buildings, even in those days. And I'd say what we are doing nowadays, by and large in this country, is not yet up to the standards it was in Germany all those years ago. So we are way, way behind most of Northern Europe. It's not just Germany, the whole of Scandinavia, for instance, has much higher levels of insulation in their buildings than we do. Very effective too.
So I think that's all we've got time for in terms of questions, really. So sorry if we didn't get to your specific question. Hopefully we covered a broad cross-section of the topics that were being asked about. I would very quickly just like to say, well, firstly, thank you to Ian. Martin will come back on in a second and just give you a formal vote of thanks, but also that the IET Solent network, who have put on this particular webinar, would just like to advertise a couple of our upcoming things while I've got your attention. So we've got a likely to be on the 17th of February, a routes to professional registration webinar. So if there are people who are interested in progressing their professional registration statuses, then that's a good one to keep an eye out for in the emails. And we've also got coming up a Fellows Spotlight lecture on the 23rd of May. Again, should be out in the emails soon, where we're going to focus on the career and story of a particular IET fellow from our local area. And then on the decarbonisation theme and energy and so on, we're in the April-May sort of time, we're looking at doing a talk on the challenges of DC links to Europe and energy sharing of grids and that sort of thing. But I would just like Martine, if she is still there, to come on and just say a final thank you to Ian, and then thank you for everyone for attending. I will say goodbye now, because when it ends quite abruptly.
Right. Yeah. Thank you, Dean. And yeah, it's a pleasure to have had this some time with Professor Ian. Thank you very much, Professor Ian, for giving us your time for shedding light on some of the interesting and yet challenging subject to which I'm sure all of you will join in something which we're going to continue to learn more about it. Again, as Professor Ian touched on the topic itself, the definition, because at time we have terms and we're not quite very clear what exactly you mean, how its applicability and how it is adaptable as well to our daily life, in particular nowadays. COVID challenge we are facing as well. So yeah, Professor Ian touching on what meaning of the carbon itself in relation to exactly the message passing out, what is the meaning of zero carbon goals and objectives, and taking us through energy hierarchy, and taking us measures and the UK government 10-point plan as well. Yeah, it has been a great pleasure to hear all those information which Professor Ian managed to go through more details, and yes, it leaves us with lots of questions, which I'm afraid it's difficult to find all answers tonight, but something which I'm sure it will be positive again to hear, to see how best we can continue to be updated on how best each and every one initiative can contribute too. So yeah, thank you very much, Professor Ian, again for having addressed those elements, which I'm sure it leaves us a lot of a question to how best our behavior can contribute to responding to taking a personal initiative to passing on those initiatives to higher levels where how policies can be made so that they are adaptable to our daily lives as well. Yeah, lesson learned as well. You touched on some other countries which are in advance comparing to where we are. Again, it's positive. That is something we're possibly going to start looking into how best we can come closer to the best practices they have implemented or managed to achieve to now. So yeah, I will thank the people who managed to join us this evening. Thank you very much. Where you are worldwide, I can imagine how in the time you managed to give to us this evening. And I will thank as well the IET Solent, which has given us this platform to learn more about decarbonization. Again, this is not the final. We're still exploring more, to which we'll be able to share and we can discuss further. So yeah, thank you again, Dean, for being assisting for being our host tonight, and given the time we have, thanks everyone for information this evening, and we have other events for IET Solent to which you are welcome to join, and yeah, we'll keep you up to date. So thank you very much. This webinar will finish tonight. Thank you. Dean, I'll pass to you. Anything you want to add?
Just like to say, I said about the Fellows Spotlight lecture, the date of that is the 23rd of March, not May. I said May. And there's been a few questions, Ian, on a few people have tried to download the energy hierarchy report from the FIMechE and managed to get a bad gateway report on the FIMechE website or something like that. So I just wonder if we could get a working link and then email it out to the attendees after the fact, because quite a few people want to read it.
I'm sorry to hear that. I will see what can be done. Yeah. I don't have much influence over the FIMechE website, but I'll see what I can do.
Yeah, see if we can find a working link, and then I'll get that sent out. So yes, once again, thank you everyone, and have a good evening.
All right, thank you all. Bye.
Thank you. Bye.